Hey, it's Mr. Staltano, and this video is going to explain how you find the mass of 1 mole, which is also known as the molar mass. So remember from before that a mole is 6.02 times 10 to the 23rd of anything. So a mole is always that number, but in this lesson we're talking about how do we find a mass of that mole, basically. So firstly, let's remember that atoms are very, very tiny, right? And so just as an example, there's about 7.5 trillion carbon atoms in the period of a sentence if you write it in pencil. So if you write a period of a sentence, it's 7.5 trillion atoms of that element carbon from the graphite in your pencil. But those atoms are too small to count. They're too tiny for us to count all those little particles. But oftentimes in chemistry, we need to know exactly how many particles are there. So then, how do we find out how many atoms there are in a substance then? Well, what we actually do is we take the mass of the substance. And this is kind of the harder part to understand, is that basically, if we know the mass of a mole of a substance, and then we know the mass of the substance itself, so we know that a mole is this many grams of a substance, and then we also know the mass of the substance we actually have, then we can actually figure out how many atoms are there because we can figure out how many moles are there. So for example, if we did the molar mass of an element like carbon is 12, and so if we had 12 grams of carbon, we would know then that we have 1 mole of carbon, which would then tell us that how many atoms are in there? Well, how many atoms are in a mole? 6.02 times 10 to the 23rd. So because we can't count the atoms, we use the mole and the molar mass in order to figure out exactly how many atoms are there, which is very useful. But we have to be careful, though, with this thing called molar mass, or the mass of 1 mole, because a mole of one substance is very different from the mole of another substance. So for example, if we said we have a pear of watermelon, that's different than a pair of oranges, right? It's 2 of each, but they have very different masses and very different properties, right? So it's the same thing for the mass of each mole of different substances. The masses are going to be very different in each of those substances, even though they both have that 6.02 times 10 to the 23rd particles in them, because that's what a mole is. Just like a pear of watermelon has 2 and a pair of oranges have 2, doesn't mean they have the same mass. So if they all have different masses, is there a way that we could quickly look at some table somewhere that could find the masses of those elements? Well, actually, yeah, there is. On the periodic table, if we look at that atomic mass, we can now use that as molar mass. So if we look, for example, we said before, carbon atom has a mass of 12 grams. That's how much 1 mole of carbon weighs on the balance. And so that means that if you have 12 grams of carbon, you're going to have 6.02 times 10 to the 23rd atoms of carbon, because you know you have 1 mole. So when we go to find the mass of an ionic compound, it's very different than finding the mass of just one element. It's similar but different. In order to find the mass of a compound, you take the elements that make up that compound and you add up their masses. So we would look on the periodic table and we would say, for example, here's an ionic compound example, which is sodium chloride, because it's got that metal and nonmetal. If we look on the periodic table, we would see that sodium has an atomic mass of 23U, and chlorine has an atomic mass of 35.5U. When you add those together, you get the mass of the compound sodium chloride, which is 58.5U. Now remember, that U stood for atomic mass units, right? It was a shorthand for that. So that was just for the atom. But now we know that actually we can use that same number and make it grams in 1 mole. So this is kind of confusing, but a single compound of sodium chloride has a mass of 58.5U. Very, very, very tiny atomic mass units, right? But a mole of sodium chloride has a mass of 58.5 grams. Grams as in we can measure it on a balance, because a mole, there are so many particles there, we can actually measure them on the chemical balance. So we literally take the same number off the periodic table that we use for the atomic mass, and we just make it grams essentially. What is the molar mass of Na2O if oxygen has a mass of 15.99U? So what do you think that is? Take a minute to think about it. We have the mass of sodium, which is up here, which is 23. So what would you get for that? Well, so if we add those up, we have 2 sodiums and we have the 1 oxygen. So we would have 23 plus 23 gives us about 46, right? And then when you add in the oxygen, because we take 2 parts sodium, 1 part oxygen, you would get 62. But the important thing is now we have grams because we're talking about a mole. So the mass of a mole is in grams, even though we're getting the same number off the periodic table. So let's take a look at a molecular compound. So this one is all nonmetals. And so basically you do the same process. You look at the periodic table for the mass of those atoms, and then you add them up. So if we want to know the molar mass of sulfur trioxide, we would take 1 sulfur atom and 3 oxygen atoms, which is what's in the formula over here, and we would look on the periodic table to see what those masses are, and we would add them up. So on the periodic table, sulfur is 32.1 U, atomic mass units, and then each oxygen is 16, but we multiply that by 3 because we have 3 oxygens. So our total mass for that is 80.1 U, and if we had just one of those compounds. But because we have a whole mole of those compounds, it's actually 80.1 grams. So if we wanted to find out the molar mass of sulfur dioxide, we would add together one sulfur, so that's 32.1, and 2 oxygens instead, and then we would get 64.1 grams per mole, which is again known as the molar mass. So we just use the periodic table to calculate these things. So we are using 6.02 times 10 to the 23rd. That's our number that's in a mole, right? And that's called Avogadro's number. But why do we use that? This is the hardest part to understand. The example to kind of help you understand is that if we were to take the mass of sodium, so just the atomic mass of 1 sodium atom, we have 11 protons there and 12 neutrons. We know the mass of the electrons is so tiny that we don't consider it, right? So really we're just adding up 11 protons plus 12 neutrons to get our atomic mass of 23 U. So a single atom of sodium has a mass of 23 U, or atomic mass units. Tiny, tiny, tiny. However, if we have exactly 6.02 times 10 to the 23rd sodium atoms, with each of those atoms having a mass of 23 U, if you were to take 6.02 times 10 to the 23rd of those and add them all up and put them on the balance, it would have a mass of 23 grams. So this is actually where this 6.02 times 10 to the 23rd number comes from, because it takes 6.02 times 10 to the 23rd of that atom or molecule or what other representative particle you're using. It takes that many of those atoms in order to have a mass of the same number, basically. So when you take any atom's mass, which is in atomic mass units, and you multiply that by 6.02 times 10 to the 23rd of that atom, for example, it would have a total mass now of that same number, but now it's grams. So that's where that comes from, essentially. And again, this is referred to as the molar mass. But the biggest thing we want to know, basically, is in order to find the molar mass, you have to A, look at the periodic table, and B, when it's a compound, you have to make sure you add up all of the elements involved that make up that compound. So you have to add up all of those numbers to get that. And that's it for the molar mass. Thanks for watching. And remember, chemistry is everywhere.